Good morning, my dear students. Today we are going to discuss about need for modulation in communication systems. My name is Dr. K.A.Shahul Hameed, Professor, EC Department, Sethu Institute of Technology, Pulloor. I have planned this session like first we are going to discuss about session objective, session input, in session input, history of communication, reason for modulation, practicability of antenna, frequency multiplexing, narrow banding, and then summary of the session, and then reference. This is the overview of this session. Session objectives. At the end of this session, the learners will be able to discuss how information exchanged in olden days, define modulation, list the important reasons for modulations, enumerate frequency translation, define wavelength, give the relationship between length of the antenna and wavelength, what is frequency multiplexing, brief narrow banding. These are the questions. These are the questions the students will be able to answer at the end of the session. I have planned this session like I have subdivided into some number of topics like history of communication, reason for modulation, practicability of antenna, frequency multiplexing, narrow banding, conclusion, and allocated time duration for each and every topic, and corresponding Bloom's level learning also I have mentioned here. I'm starting with the first topic, history of communication. We all know that in olden days, the people are exchanged information between two extreme ends using different ways. One famous way is pigeons. They have used pigeons to transfer information from one place to another place. Not exactly transfer, send. So pigeons are used to send the message from one place to another place. Here the message is written in a paper and it's tied in the neck of the pigeon, and the pigeon will fly from one place to another place, and the pigeons generally trained to travel for fly for more than 100 miles. This is one way of communication in olden days. Another way is horse rider. Horse rider generally used to carry the information from one place to another place. This is another type of communication used in olden days. Later, we have used post letters, and we can send letters from one place to another place. And important thing is we have to write the address, and a postman will take the letter from one place to another place and deliver to the destination. This slide shows the basic building blocks of communication system. Generally, communication system means exchange of information, transfer information from one place to another place. Basic block of this communication system is information source. Without source, it's not possible to send message from one place to another place. So first and foremost thing is message source, information source. Here we have lot of information source. Voice is information. Message, the sense writing letters is information, something like that. So source of information is very important, and this source should be transferred from one place to another place. Hence, the first block is information source. Next one is the information source. Sometimes if you are considering information source as a voice signal, then the voice signal should be converted into electrical signal. That's very important part of communication system. Generally, message in the form of sound, picture, video, something like that, this should be transferred from one place to another place. So these information should be transferred into electrical form. Hence we require a transducer. So the transducer will convert the message in the raw format into electrical information. That electrical information is transmitted using the transmitter. The transmitter will send the data to the receiver via channel, communication channel. The receiver will receive, and the received signal is given to the output transducer. The output transducer will convert the received information suitable for the destination. Here, important part of this communication blocks is noise. Noise will always corrupt the transmission process. That is, the signal will be affected by noise. In the presence of noise, the receiver should be able to receive the original information and given to the destination. Hence, we have to make the signal suitable for communication over the channel. That part is very important part that is done by the transmitter. Transmitter play a vital role in making or converting the signal into the form which is very suitable for transmitting over or sending over communication channel. So we need to know what is the need for modulation. Baseband signal produced by various information sources are not always suitable for direct transmission via a communication channel. These signals usually modified to facilitate transmission. That process is called modulation. In this process, the baseband signal is used to modify some parameter of the high frequency carrier signal. Generally, the carrier signals will be always a sinusoidal signal with high frequency. One of its parameters, such as amplitude, frequency or phase, is varied in accordance with the baseband signal m of t. Depends upon the parameter, we can classify the modulation into amplitude modulation, frequency modulation or phase modulation. In amplitude modulation, amplitude of the carrier signal is varied in accordance with the message amplitude. In frequency modulation, frequency of the carrier signal has been varied in accordance with the message amplitude. And almost frequency modulation and phase modulation almost same, depends upon the situation, almost same. This figure shows carrier signal and a message signal. You can see the first one is carrier signal C of t, and second one is the message signal. You can easily identify which signal is high frequency signal and which frequency is low frequency signal. By seeing this, first signal is by seeing this we can say that the first signal is high frequency signal and the second signal is low frequency signal. But if somebody not able to understand not able to say which one is high frequency and low frequency, a simple way to identify is you can easily count the number of zero crossing. When you are seeing these two signal, first signal has more number of zero crossing. Zero crossing is nothing but the place at which the waveform move from positive cycle to negative cycle. So when you are seeing a portion of the signal of the message and the carrier signal, message signal you can find 1, 2, 3, 4, 5 zero crossing, but at the same time if you are seeing carrier signal you can find more number of zero crossing. If you find more number of zero crossing, you can say that this is high frequency signal. Here the first one is the high frequency carrier signal and the second one is the low frequency message signal m of t. So here this figure shows the graphical representation of amplitude modulated signal and frequency modulated signal. You can find the changes in amplitude in amplitude modulated signal. The envelope is equal to the message envelope, and in frequency modulation the frequency of the carrier wave has been varied in accordance with the message amplitude. Whenever and the amplitude of the message signal is vary. The frequency of the carrier signal may be increased or decreased, depends upon the mathematical equation. Generally, the process of modulation in the communication system increases its complexity. Modulation is used to facilitate the transmission. So we should know the basic reason for modulation. If modulation is not employed, the system engineer would confront the following problems. One is practicability of antenna, frequency multiplexing, and narrow banding. We will discuss about each one in detail the next slide. First one is practicability of antenna. I would like to say important relationship between length of the antenna and wavelength. These two are closely related, and because of this relationship, we used to carry cell phone in our pocket. The relationship is length of the antenna is directly proportional to wavelength. We all know what is wavelength. Wavelength is equal to C by F. C is the C is the speed of light, 3 into 10 power 8 meter per second, and the frequency of the carrier. Here, L is directly proportional to lambda. When you are equating it, L is equal to lambda by 4. Hence, it is equal to C by 4F in meters. So, from this relationship, we can understand that if frequency is increasing, length of the antenna will get decreased. This is the relationship. Because of that, we are all using high frequency carrier signal in mobile communication. Because of that, we are using cell phone in our packet. This is the main relationship. And next slide will give you detailed explanation about how the length of the antenna will get decreased when the frequency of the carrier signal is increased. For example, we have taken one or two frequency. For example, f is equal to 1 hertz. When the frequency is 1 hertz, length of the antenna L is equal to C by 4, which is equal to 3 to 10 power 8 by 4, which gives 0.75 into 10 power 8 meters. It is not possible to have very big antenna to receive a low frequency signal. At the same time, if the frequency is increased to 100 hertz, the length of the antenna is 0.775 into 10 power 6 meter. So, when we are determining the length of the antenna for high frequency signal, the length of the antenna will get decreased. For example, if the frequency is 10 power 100 megahertz, then the length of the antenna is 0.75 meter. So we know that very high frequency is used, that is micro frequency is used in mobile communication system at the order of gigahertz. So we can have very small antenna or strip antennas in our mobile systems. Next one is frequency multiplexing. Frequency multiplexing. Multiplexing is used to send more than one message via communication channel. I would like to explain this concept using analogy. For example, you consider Madurai and Chennai city, that is two major cities. There is only one track is available for train. So there should be several train must go to Chennai, as well as there may be lot of train must come to Madurai, but we have only one track. So the trains will be go to Chennai, and from Chennai to Madurai or passed in a time shared manner. So there is only one channel, but the trains are sharing the track in a time slots. This is called multiplexing. So we are sending more than one train from Madurai to Chennai, as well as Chennai to Madurai. but we have only one track. This concept is applicable, is analogous to understand communication, multiplexing. Here, we have several different signals. Frequency multiplexing is used to transmit all these signal along a single communication channel in such a way that at the receiving end, the signal be separately recovered and distinguishable from each other. Next one is narrowbanding. Practicability of antenna could be used to understand the concept of narrowbanding. For example, the frequency range of speech signal is 20 Hz to 3500 Hz. To transmit this speech signal directly from the antenna requires different size of antenna. Using the relationship length of the antenna is directly proportional to lambda. To transmit one band edge requires very big dimension antenna than other band edge, because 20 Hz signal require a very big dimension antenna, and also 3500 Hz require again considerably small antenna, but it is also a very big in size. More importantly, it is not possible to design antenna for several kilometer length, and also it is very difficult to carry the antenna when the transmitter or receiver is on move. Assume that the audio range extends from 50 Hz to 10 power 4 Hz. That is, if you are translating low frequency to high frequency, the ratio of highest frequency to lowest is 200. Therefore, antenna suitable for use at one end of the range would be entirely too short or too long for other end. Suppose the audio spectrum is translated to high frequency from say 10 power 6 to 10 power 6 plus 50 to 10 power 6 plus 10 power 4, then the ratio of highest to lowest frequency would be around 1.01. Modulation process is used to change the wideband signal to narrowband signal. So we are at the end of the session. Summary of this session. In this session, we learn to define modulation, list the reason for modulation, define amplitude modulation and frequency modulation, determine length of the antenna to transmit the speech signal, brief about practicability of antenna. So references are Simon Atkins, communication system, top and shell link, principles of communication system, LATI, digital and analog modulation system. Thank you.